We're officially streaming, and let me check the chat here. Oh, hey, we got a lot of people here. All right. Yes, we got DD here. That's definitely nostalgic. Good to see you again. Raven, what's up? As always, the sniper. Crypto Chica, our legendary instructor. Thanks for doing such an amazing job so far, and I hope that people have been telling you how amazing you've been doing. Generous Kid, what's up? As always, great to see you. Ngayo, hello. Bread, what's up? Brett, I saw you message me, but I haven't gotten around to responding yet. And what's up, Snowmobiles, the other legendary instructor. Snowmobiles, as always, kicking absolute butt, our OG. So yeah, what's up? Raven, who is that? Who's that? Oh, I don't. What anime is that from? We got some other people in here. We got MPI. Good to see you again. That's a new profile picture. What's the context for that? Greg, how you doing? Davon, what's up? Courtside, hello. Courtside, I know you're already on chapter 4. You're an absolute wizard. Keep on going with that awesome stuff. I know that chapter 4 kind of threw you off a little bit, but I know you can do it. And Amethyst, what is going on? So happy to have you here as well. And I also hope that people are thanking you for doing a great job too. All the instructors during this boot camp have done a great job. Hello. You say goodbye, I say hello. Doo doo. Great song. I have no idea what that says, Raven, but sounds pretty cool. Instructors rock. True, DD, true. Can we get a bunch of hearts on that? Facts. I'm setting up the lesson right now for all of you. One sec. All right. I'm just gonna do a little bit more preparation, and I'm not looking at the chat right now because I'm trying to do stuff in the playground. But give me a moment here so that we can have a nice lesson today. Okay. Okay. Cool. All set up. Notorious B.I.G. Right? Yeah. That's a band. King of New York. One of nice. Looks cool, MPI. So let me go ahead and share my screen here. There we go. Actually, I'm gonna test it. Hold on, I'm gonna stop for a second. Let me do that again. I want to see if is there a way for me to. Oh, okay, no, this is good. Okay, cool. Yeah, so sorry about that. So there's the stream. I'm gonna wait a couple more minutes for people to roll on in here. I'm gonna give it another minute, and then we'll be off to the races for our what are we doing today? Chapter 3, day 1 to Chapter 3, day 3. So wow, I actually got a lot to do today. We got resources. That's gonna be a lot. Oh no, and references as well. So yeah, we got a lot to do, ladies and gents. But we got this. Who else we got in here? We got Crossstick. What's up? Let me see if this can. Let me try something really quick. Workshop. Okay. So so we've already done a week of workshops. So how's everyone feeling so far? Is this content kind of hard? Is it maybe getting easier? Are you liking Cadence at all? Difficult this is? Yeah, well, unfortunately it's about to get a little more difficult, but I'm sure that, as with all coding, the way that you get better is to like just do it, right? Like struggle with it, keep trying. I wish I could use something else in the playground. Yeah, I know. That is true, DD. I know that their team keeps saying they want to, they want to keep improving it, but it's taken a while. It's taught better than my class at the university. Let's go, courtside. Yes, sir. Nice. That's good to hear. Maybe I'll be a teacher one day. Well, I guess I am already, right? But maybe I'll be like a college professor one day. Is Ayasumi here? Oh no, not yet. Okay. You are to me? Thanks, DD. We got Numini. What's going on, Numini? Witty's here. Hey there. And Shizu, what's up? All right, so let's give it a go. Yeah. So before we get started today, just want to give a quick mention that we're going to cover resources today. So basically, resources are like what make Cadence Cadence. But because of that, it's also the most complicated, chapter. So if you get confused today, it's not your fault. It's just a kind of difficult concept to grasp. That being said, like I said before, I think the best way to learn this stuff is to struggle. So hopefully, with a lot of struggling, you'll get there eventually. The teacher, yeah, I'll try that out. Yeah, I'll try that out, MPI. Some good advice. Also, quick update. So we just added Russian translation to all the chapters. So under each chapter, like for example, chapter 3, day 1, we're going to do today, there's English, which is what appears immediately. That's the readme.md file. If you want to check out Russian, you can go to the _RU, and it's a whole, look at it's all translated for you. So really awesome stuff. And thanks so much to Entry for doing that. Entry, are you here? No, you're not. But thanks to Entry for doing that. And it's also available entirely in Chinese. So if you go and click on ZH, it's also all in Chinese as well. So yeah, that's the hope. So cool. All right, so with that being said, let's do this thing. So today we're going to be talking about resources, right? And to give some context to this, we should kind of review structs. So remember in the last workshop we talked about structs where let me make sure. Okay, yeah, we talked about structs where they're basically containers of information, right? So we have a struct here in a contract in the first account. We have a couple simple things. We have a test dictionary that maps an integer to a test struct. The test struct has an ID and a name inside of it, right? And also, we can add a test to this by passing in an ID and a name and mapping self.test at the ID, which is an integer, right, to a test struct. So why don't we go ahead and deploy this contract? And let's go to a transaction and hope that things work in our favor. So let's, in this execute function, let's call hello world dot add test, okay? And we need to pass in an ID and a name. So let's pass in, I don't know, 10, and the name is going to be Raven, okay? So we're going to call this transaction, hopefully, and if hopefully this works, we can log done, all right? That way we get some feedback on our console. So let's send this, and we get done, right? So we added it to the contract, awesome. Now, theoretically, right, we just call this add test function. And, this is all review, by the way. You should all know this already. So we pass in an ID and a name. It created the test struct right here, which contains those two pieces of information and maps it to the ID, right? So theoretically, right now, 10 should map to a test struct with an ID of 10 and a name of Raven. So let's try it out. In our script, let's return a hello world.test struct. And before we do that, we have to import hello world from OX01, right? So let's return hello world.test at 10, right? Now, remember from last lesson, what's the problem with this? Anyone remember what the issue with this is? It says mismatch types expected hello world.test got an optional. Why is it giving us an optional here when we want this? Yeah, exactly, I know. So because we're reading into a dictionary, Cadence doesn't know a value exists there, right? So in order to do this, we either have to unwrap it with the exclamation mark, we have to add a panic, or the best way to do this is when you're in a script, make the return type an optional. That way, whoever calls it, which right now is just us, but in the real world, your DApp or application that's using the script to read information can handle the case where it's nil. So let's go ahead and run this with execute, and we should get a value back, right? So we get a test that has a field with an ID of 10 and a name of Raven, which is shown right here, okay? Now, if we were to put in like 5, it would hopefully return nil. So let's try it, and we get nil, right? So, or null. Cool. So that makes sense. Okay, so that's a struct. Now we dive into resources. Okay, so resources, if you remember back from chapter 1, day 1, Cadence is a resource-oriented programming languages because of this, right? So this is the main crux of what what Cadence really is. Okay, so without reading too much, let's just go into our contract and make a resource. So spoiler alert, it's pretty much exactly the same as the struct, except you change struct to resource. So public resource. Let's call this a test resource. All right. And inside here, we're going to make a public let ID, which is an int, and I don't know, public let name. So same thing as the struct, okay? Now, to initialize this, I'm just going to copy and paste this as well, just to make our time or not waste time. Okay? So you can see it's actually very similar. We have a struct here, and we have a resource right here. They're both declared using the pub and then resource and then the name of the resource or the type, right? Like what we want the type to be called, and then it contains information. So in this case, it contains an ID and it contains a name. Now, now that we have this done, this is when we start asking ourselves, well, what's the difference between a struct and a resource? So that's what we're going to walk through right now, the differences between these two. So first of all, resources cannot be copied. So if we were to go into a script, let's get rid of all this for a second. You can say, let test equals a hello world dot test with an ID of 10 and a name of Jacob, right? And then the next line, you can say let test2 or test copy equals test. This is totally fine, right? You can do this with structs. You can't do this with resources. With resources, if you were to put a resource in the test variable and then set test copy to the test variable, it would no longer be inside of here. Whereas in this case, both of them still exist. So we can log test and we can log test copy, right? So if we run this script, both of them exist, right? They're both right here. But if we were to use a resource, this one would no longer exist, okay? So resources are what we call moved instead of copied. So you would move the resource from here to here, which means it would no longer be in this one, okay? So that's difference number one. Difference number two is they cannot be lost or overwritten. So unlike a struct where you can overwrite it, so you can say let test overwritten, or you could actually, no, a better example is to say, let's say var test, and then say, okay, let test equals, and then we assign it to another one. Get rid of these two for now. So with structs, you can do this, okay, and change some things in here. You can define a test variable, and then you can set test to a different struct. You can't do this with resources. You can't overwrite a variable with a resource inside of it, which makes it very hard to lose, and we'll get into that in a bit as well. Another one is you cannot create them whenever you want. So with a struct, you can see that in this script, we're allowed to create a struct in the script, right? We're doing that right here. With resources, you can't do that. You can only ever create resources inside of a smart contract. So you cannot create structs, or you cannot create resources inside of a transaction or a script, only smart contracts, okay? Number four is you must be extremely explicit about how you handle them. We'll dive into this in a second. And also resources are just generally a lot harder to deal with. Okay, so let's test a lot of these theories out. So what I'm going to do, just for the sake of clarity, is get rid of these things. Just that it's a lot easier for us to look at this. Okay, and I'm going to change this to create test. Create test. Okay, and we're going to get rid of all these things. All right, cool. So what we want to do is we want to create a test resource. Now with a struct, it was pretty easy. All you did was you just said like test and you opened up some brackets and you put some information here. With a resource, it's very different. Let's say let test, and then here's difference number one. Instead of saying equals with a resource, you use the move operator, right? We move resources around. They don't just equal things, we move them around. So then the next difference is you say create. So to make a resource, you have to actually use this create keyword, right? And create will allow you to create a new resource. And then let's just call this test for now. Create test. And then it's normal. So you pass in the IDs and all the information right here. Okay? So this is difference number one, is that you don't use equals, you use the move operator, which is it's literally just like this symbol and then this symbol. And then you use the create keyword when you want to create a resource just like that. Now, immediately, you're going to see we have a problem. It says loss of resource. So why is it saying that? Well, it's because if we go back here, it's, one of our rules is that they cannot be lost, right? So you can't just leave a resource dangling. Now, what that means in Cadence sometimes, or in programming, is that you can't just like leave it alone. You have to do something with this. You have to either store it, or you have to destroy it, or move it somewhere else. So there's three options. So three options when dealing with resources. You can, 1, simply destroy it, 2, move it, or 3, store it. Okay? So in this case, we have nowhere to store it to because we haven't made like a dictionary for it yet. So let's just destroy it. Let's see what it looks like to destroy it. Let's destroy test. All right? And now it's happy. So what destroy does is it takes the resource and basically just gets rid of it. It blows it up. It's now, destroyed. It's gone forever. Okay? So that's what it means to destroy it. Now, there's another one called move it, right? So let's actually move it somewhere. Why don't we actually move it to the return value? So let's make this function return a test resource. Now, here's difference number 3, right? Or here's like another thing that's different. So first, we covered the move operator, we covered create. Here's another difference. You have to put an @ symbol in front of every type. So the @ symbol symbolizes that this is a resource type, okay? So we're returning a resource type called test. Now what you can do is we can return it, but you can't just say return test. You have to move it into the return value. So every time you're moving a resource, you have to move it somewhere, okay? So in this case, we're taking test and we're moving it into the return value. All right? Awesome. So let's go ahead and deploy this. It's now deployed. And let's go to a script, right? And test this function out. So let's say let test, and then I'm gonna put some mistakes in here, and you have to tell me what the errors are, okay? So let test, it's going to be a hello world dot test type, and it's going to equal hello world dot create test, and we're going to pass in 10 and another name which is courtside. So there's 2 errors on this line. Can anyone tell me what the errors are? I made 2 mistakes in this line. So yep, first of all, I need the move operator. So this can't be equal to that. We're gonna have to move it. And @ exactly. So it has to be @ okay? So because this is the type, it's not a struct, it's a resource. So we have to put the @ symbol in front of it. Now we're getting another error, which is basically just, okay, well, all these errors are kind of, they're not correct, but this is the real error, loss of resource. So we have to do something with it. Now what we can do is let's just log test.id, log test.name, and then let's destroy it right after. Okay? So let's go ahead and click execute, or let's go here. And you can see we get 10 courtside, and then we don't return anything, so it returns void. In programming, void just means you don't return anything. Okay? So there we go. Boom. Done. That is resources in a nutshell. So where does it go when it's returned? So right here, right? So when you return a value, that just means that the function is giving you a value back. So here we first, create the resource and store it in test variable. And then here we send test back to the caller, right? So then in here in the script, that's why when we call hello world.create test, this is returning a resource, and then we're moving it into this test variable. Does that make more sense? Yeah. So it's the same thing with all, like, it's the same thing with everything. Like when you return an int, or like when you're in a script, right, and you return a string, and you like return 10 or something, like that's sending 10 to this return value, so that when someone calls this script, that they're getting that value back. It's like a way of getting a value back from a function. Okay, so that's resources for you in a nutshell. I'm trying to think of what other things do I want here. Yeah, so that I'm pretty sure that's all this chapter. So not so bad, right? Not so bad. So why don't we actually? This is one of your quests. Let's do your quest together. So here's the quest. So you haven't really looked at this problem at all, but I told you there's one error here, there's two errors here, and there's one error here. So can anyone in the chat like label your answer with if it's 1, like 2, 3, or 4, and give me the like answer? And you're only allowed to give one answer. You can't give multiple. So Ngaio said 1 is the @ symbol. So can anyone give the second error? That's a great job, Ngaio. Good stuff. So Courtside said 2 is the move operator. Perfect. Can anyone give me the third one? Yep. So that's the fourth one, DD. So who can give me the last one? And you're only allowed to give one answer. So what are the brave souls we have to give the next one? Maybe Raven's got it. All right. Well, Courtside gave another one, so we'll just use that. Okay. So it's create, right? So that's the 4, right? So boom, there's your quest right there. So if we just played the I Spy game and you answered number 4, perfect. So let's go back to our example though. All right. Good stuff. So let me get rid of some of these comments so that we can keep on going. And what we're going to talk about now is how to store these things. So let's make a new dictionary called tests, and it's going to be we're going to map a integer, which is the ID, to the resource itself. So test. Now, anyone see an error here? And I can guarantee you that no one's going to be able to get it right. But what do you think the error is here? Yes, so Ngaio says we have to add an @ symbol here, which you would think is correct, right? And to be honest with you, I don't really know why it's not correct. But, well, I do know why, but I don't know like why it was done. The answer is because when you're dealing with dictionaries or arrays, if you have a resource inside, you always put it on the outside. Okay, so even though it looks like this is like a test struct, it's not. You always put the @ symbol outside of the whole type, so you don't put it inside. Okay, so I know kind of confusing, but you just have to deal with it. So then in here we can say self.tests, and remember we can't say equals empty dictionary. You can't do that. You have to say you have to move it, right? Because it's a dictionary that deals with resources. So if you're dealing with resources, you have to use the move operator down here. That's why I keep taking the course. Raven loves destroying them all. It's his favorite thing. All right. So now we've made a dictionary that can hopefully store a bunch of tests inside of it. So actually, I kind of made a mistake. Sorry, I want to do arrays first. So let me just change this really quickly. Okay, so we're actually going to do arrays first. So I move in empty array, and it's an array of tests. And again, you don't put it on the inside, right? You don't put it here. You put it on the outside. All right. So let's go ahead and figure out how to deposit a test to here. So let's go ahead and deposit test. So what we're going to do is we're going to send in an ID and a name. And actually, wait, how do I do it? Wait, sorry, let me see how. I want to make sure I do it exactly like I do in here. Oh, okay, sorry. Okay, sorry. So what I'm gonna do is I'm gonna pass in a test like this, okay? And this isn't gonna return anything because we're adding it to the array here. So how do we go ahead and add this test to this array? Well, it's not too bad. You just say self.test.append, and you want to append the element, right? So with any arrays, remember I showed you before how to add and remove from arrays. You do self.test.append, and if you're confused about this, you can go back to chapter 2. And then we pass in the test, right? Just like that. So actually really easy. And that's exactly how we do it right here as well. So you basically just say self.test.append. That means we're adding an element. And you can't just say test. you have to tell Cadence you're moving it into the array. So again, anytime you're moving a a resource, you have to make sure you put the move operator. So pretty simple, right? That's how you deposit a test. Now, if we want to public function withdraw a test, let's ask for a certain ID, and we're going to return a test resource. Now, in here, all you do is you say, okay, we want to say return, right? Actually, we'll do it a different way. We're going to say let test. We're going to remove, so self.test, or wait, I want to make sure. Okay, yeah, self.test.remove, and then it says, okay, where do you want to move it from? Now remember, when you have an array, each of the elements in the array has a certain index, right? Like 0, it starts at 0, then 1, 2, 3, 4, 5. So that's all it's going to do. It's going to say, okay, at which index you want to take it out from. So you pass in an index, and you say, okay, we want to remove it at this index, right? And then we're going to remove it from the array, move it into test here, and then we're going to return test. So that is how you add and remove arrays from, or that is how you add and remove resources from a, resource array. All right. Anyone have any questions about this? I'm going to pause for a second in case anyone has any questions. Now remember, so far this is all normal, right? Like when you add or remove like strings from an array, you use append, or when you're depositing, use append. When you're withdrawing a string from an array, you use remove. The only difference here is we're using the move operator. That's really the only difference. No questions, just headaches. Sorry, Numini. So far it's actually really similar. It's just using the move operator to move everything everywhere. Let's see some people type in, so I'm not gonna continue until we answer some of these questions. So Bam has a question. We store resources in the contract. Where do they go if we remove the contract? They're gone forever. So if you remove a contract, all the resources are gone. Or like pretty much anything that's ever stored in the contract is just gone. It's kind of weird, actually. Because like Bam, as you know, you have to like define a destroy function, right? When you have like nested resources, but for contracts you don't. Scary, yeah. Also, while we're paused for a second, I want you right now to think about what a resource is, right? So we're doing a lot of like weird like resource stuff in Cadence right now, but think about some of the attributes of a resource, right? It can't be copied, right? It needs to be moved everywhere. They're pretty important, right? They hold information. What do you think a resource represents in the real world? Or what do you think one example of a resource is in the real world? Anyone have any guesses? Yeah, an NFT. Exactly. So in the real world, all of your NFTs, and it's cool actually because we're at a point in the course where everything we do is going to start relating to the real world a little bit. A resource in the real world is actually, you can use it as like an NFT. So your Flovatars, your goated goats, your floats, all these things, they're always a public resource NFT. So pretty cool, right? And soon enough, we're going to be talking about Nfc Collections. So it could be something else. Oh, of course. I mean, it could be literally anything. Like NFTs are, of course, like the most popular use case. But for example, on the Float platform, like all of your events, they're also resources, right? They're not the events themselves are not resource or not NFTs, but they're also resources because they contain information, and you don't want to ever lose your event, and you don't want it to be copied or anything like that. So, yeah, it can be literally anything. it's really just a container of data that you want to be extra secure about. That's really what it is. Poor Raven's dying over there. Raven's on the 4th round of the boot camp, dying out from a headache. Oh, it makes me laugh every time. Why did they draw the bird like that? So it's a class? Um, yeah. It's a class. I would say no. I think that's stretching it a bit. Um, because a class in Java or like in object-oriented programming, I feel like is supposed to be almost like a template, whereas a resource is like an actual asset. But kind of. I mean, I guess like I think it's hard to compare the two because like Web3 is so different from that. But I mean, I guess kind of, yeah. All right, cool. So that's adding and removing from arrays. So what we're going to do next is we're going to get rid of these two, and we're going to add and remove from a dictionary. So let's map an int to a test. And by the way, the reason that I'm like specifically going over how to remove resources from arrays and dictionaries and add to them is because like most often resources are stored in dictionaries and arrays. In fact, they always are really. So like it's a good thing to know how to do it, and it gets a little more complicated when we get to dictionaries. So let's do that together. Okay, so let's deposit to it. So there's actually multiple ways to deposit to a dictionary. Remember before we were talking about like you can do like self.dictionary like at something equals value, or like at key equals value, but you can also do like self.dictionary dot insert like key value. So we're gonna go over both of these together. I definitely it's a little different though. Why is Raven like editing his emoji? Raven. Um, as an array, I couldn't pay attention. Raven was like changing his emoji over here. Is an array a collection of NFTs? Yeah. Well, no, it's not your fault, Raven. It's totally fine. But Numini, like I mean, it's sort of like a container, right? Like you know how like an array is like always a container, but how we actually represent. Okay, this is going to confuse everybody, but in a couple of chapters, we actually use another resource as a collection of NFTs. So we're going to store our NFTs, which are resources, inside of another resource that's called collection. And that resource will contain a dictionary of NFTs. So we'll get there. We'll get there. True. We need to make the lesson memorable. True, Raven. You're good at that. And the sniper. All right, so let's go ahead and deposit this, shall we? So let's say self.test. We're going to do it the better way, in my opinion, is at test. Actually, I'll ask all of you. So what should the key be? If we want to map the ID of the test, right, which is an integer, what should we put in these brackets? Let's make this more collaborative. See if anyone can get it. So we want to map. Yeah, exactly, Ngayo. So test.id, right? We're mapping the test ID in here, and then remember you would think you would put equals. You don't. You put move. You move in the test variable just like that. Now, of course, let me comment these out really quickly. Okay. But what are these? Okay, yeah. So I don't know. There's weird errors, but I wish it was more readable. But anyway, there's an error here. So you would think, and I'm sorry, Ngayo, you're gonna hate this so much, but you would think you just put move here. Okay. Well, spoiler alert, it's a little different. You actually have to put this right here. All right. So it's a force move operator. So what the heck does that mean? Well, and by the way, this is probably the most fun operator you're ever gonna see. Yeah. Okay, I was like, what? I knew you would not like this. But yeah, so this is probably the most exciting little piece of syntax you're gonna get. So if any of you are wondering, Jacob's favorite piece of syntax is arrow dash exclamation mark. Woohoo! So what this means is this is a this is a force move operator. So what a force move operator means is well, actually, let's take a step back. So remember one of the things I told you about resources is that they can't be overwritten. Well, there's a problem here, right? What if a resource is mapped, right, 10 to a resource, right? Now what happens if you pass in another one that also has ID 10? What's going to happen if we try and move that resource into here? It's going to overwrite it, right? And that's really bad. So because cadence is amazing and it helps you may the force you with you. That's great, Bam. That's so funny. Um, but because cadence, and this is one of the things I told you in the beginning, is that like Solidity like sucks because it like makes it so hard for the developer. Cadence actually makes it really easy for the developer, and I know that you hate this, NGIO, but it actually is really helpful because it tells the developer, hey, you're not allowed to do this because if you did, there's a chance that you might overwrite something, and you probably don't want that. Okay. So the way to do this is to put this force move operator, which means if a resource already exists at this key, don't do this. Panic and abort the program. If it doesn't, then put it there. Okay, so this means if something already exists there, panic and abort the program. If something does not exist there, put it there. Okay, so even though it looks wonky, it actually is really helpful for the developer to not mess up. Okay, so this makes it so that you can't overwrite resources. Now, there's a second way to do it, and I'm sorry, NGIO. I mean, NGIO's gonna if NGIO didn't like this one, you're gonna hate this next one. But there's a little bit of okay, so there's a difference. So this is way number one. Way number two is different. Now, the reason there's another way to do this is because what if you wanted to handle the case where you wanted to remove something if it already was there, but still put this there, right? But you wanted to remove the previous one. Well, you can use something called double move operator. So, oh God. So double move operator is you say let old test, you move out self.tests at test.id, and then you move in the new one. So it's a double move operator. Okay. So again, you take what already exists. Yeah, Cortez laughing. So you take what already exists, you move it into old test, and then you move the new one into here. Then what you can do is you can do stuff with old test, right? You could return it, you could read its value and store it somewhere else, or you could just destroy it. I don't know. So let's just destroy it. Let's just say destroy old test. All right. So there we go. I hate you, Jacob. Oh my God. All right, someone ban Numini really quick. Right. So that's how that works. All right, but most often you're going to see it done this first way. So let's just delete these things and let's bring it back to here. Okay, so most often you're going to see it this way. All right. So let's go ahead and withdraw, which this is going to be even more of a, well, actually not yet. When we get to references, it'll be bad, but this is actually not that bad at all. So let's go down here. Okay. Oh, wait, that's all that. Sorry, okay. Yeah, all right, cool. So let's say let test, right? We're going to remove it. So, and this is no longer index, this is key now, right? So we want to remove one with a certain key, okay? Actually, let's just call it ID because we want to remove one with a certain ID and that represents the key. So we want to remove self dot test dot remove, and to remove it, you pass in the key, which is in this case ID, all right? Now we're going to take the test and we're going to return it. Cool. Now there's a problem here. It says mismatch types. It expected hello world.test but got an optional. So as always, you can fix it by putting this here. or you can fix it by putting this here. But the way you'll most often see it is you'll see people panicking on this line and say a resource does not exist at this ID. Okay? So you'll remove it from the dictionary, and if this is an optional, meaning nothing was actually at that ID, you panic. Otherwise, you move it into test and then you return it. Cool? We all still alive and breathing? Or are we dying out on the inside? All right, looks like Numini's doing all right. Let's go. Just a little. Still dying inside though. That's wow. There's nothing better than being a teacher and all your students are just dead. That's great to hear, guys. Good job. That's awesome. I'm toast. Oh, great. Oh, great. Yeah, true, Snowmobiles, true. Yeah, I love when my course is winning. When all my students are dead and the course is beating them out, that's great. Listen, guys, if you can't handle it, you can't handle it, right? Listen, please give up. Honestly, at this point, I won't have to give you a certificate. No, no. Buzz, get back here. Buzz, get back here. Yeah, true. Float scarcity. Yeah, listen, guys, give up. No, I'm just kidding. Stay. Definitely stay. I want this bad. I know you can do it, DD. I know you can do it. You got this. All right. So that is chapter 3, day 2 for you. Now, if that wasn't enough, we have one more for you. But look how short it is. It's really short, right? So not that bad at all. Okay, you can't blame me. All right. So here we have a problem. Okay, so let's just delete some stuff really quickly. So what do we have right now? Well, we have a contract that has a test dictionary that maps the ID of a test to the resource. We have a resource called test, right? Whatever, we already know that. We have a function that we can deposit a resource, and we have a function that we can withdraw a resource. Now, can someone give me a hint, or can someone answer me this? If I deployed this contract right now, would this contract be useful at all? Would we be able to do anything? And if not, why? Let's see who can get this one. This is actually going to be a pretty interesting one. Yeah, we need to create. So courtside, what's the problem with the current contract? There's no function to create the resource. So why is that a problem? Why can't we just do that in the transaction? Yeah, exactly. So with a bit of teamwork, we've come to the conclusion that only the contract can create resources. So in order for this contract to be useful at all, we have to have a function called public function create test that returns a test back to the caller. So return create test, right? Great job. And we pass in the ID, name, and that has to come from right here. All right? Good stuff. Good stuff. So let's go ahead and deploy this contract. And the playground wants to be annoying. That's great. Let's go ahead and deploy it to number 2, maybe. Deploy. And it's at number 2. All right. So what we can do is we can test some of this stuff out. So let's call this deposit. And let's make another one called withdraw. Right. So let's go ahead into the deposit one. We're going to import it from account 2 because we had to redeploy it here. And what we're going to do right now is we're going to first create a resource and then deposit it to the contract. Okay, so let's go ahead and do that together. So let's say let test be a hello world .create test. Now we have to pass in an ID and a name. Let's do that up here. ID is a int and a name is a string. And it says loss of resource. So for now, let's just destroy it. Okay. So right now, this transaction is going to create a test and then destroy it. But what we want to do is we want to deposit it to our dictionary right here. And we have a function to do that because we're so awesome called deposit test. So we can say hello world dot deposit test and pass in the test, right? And we should be good to go after that. So then we can log, yay, we deposited it. Cool. So let's pass in an ID, 10, and the name is going to be N Gaio, right? Or actually, in old cadence, you used to do that, but you don't see that anymore. So let's pass this in. Oh, Playground. Man, I do not like you, Playground. You are not good to me. You are mean, actually. You are very mean. Please. Yay! Okay, it won. It won. It won. Okay, we did it. 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 So, Brad, that always kills me. All right, now it's. Yep, it's not a. Yep. Cool. So it says, "Yay, we deposited." Now this is great. Now I want someone to, sort of figure this out for me. We just deployed, or we just created a test and deposited it to this test dictionary. All right, that's pretty cool. Can someone tell me how would we read the name, right? This name. How would we right now read the name of this test resource? Any guesses? How would we read the name of it? Let's say we knew that a resource was mapped 10 to a test that had 10 and NGIO in it, right? How would we read that name? What are the steps we'd have to do? And you can just type in English. You don't have to do it in code. You have to write a script. Yep. So you have to write a script. And what would you have to do in the script? How would you get to this test? How would you get to it? I think I've stumped everybody. Nobody knows? Start throwing out some guesses. Don't be shy. Could be totally wrong. I don't care. The question is, how would I get to this test right now? If I know there's something in here like that maps 10 to test, how would I read the name of this test right now? You got to pull it out of the resource. What resource, Numini? How would I get to this test to read the name of it? I'll give you a hint. There's actually a function here to do that. I think I just gave it away. no, not that, Numini. I mean, like, how would we actually get this resource in a script, right? Because MPI said, well, we have to write a script, right, to read the name of it. But how would we even get to this resource right now? Or how would we get to this test resource? You don't know? Let's see if the instructors can give it a try. Any of the instructors know? How would we get to this test resource right now? No idea? Stop him. Yes, Crypto Chica got it, right? So good. So right now, to get to the test resource, we'd have to withdraw it, right? So we'd have to withdraw it, right? And then log the return value .name, right? So we could write a transaction to do that, right? So inside of here, we would say, all right, let test equals hello world .withdraw test, and pass in the ID, right? So the ID we know there is 10, right? And then we would simply like log, test.name, and then we'd have to move it back, right? So then we have to say hello world .deposit test and then put the test back in. Now, how annoying is that? It's so annoying, right? In order to even read, right? So yeah, you can, Bam, you can, but yeah, like that's whatever. So in order to actually read, right? Yeah. So what Bam's saying is you can do this in a script too. You can, right? But that's sort of like, whatever. In order to read the name of the resource, you'd have to withdraw it, right? Read the name and then deposit it back. So let's say like, okay, let's get rid of this log. Let's try it. So let's try it with like 10, for example, because we know 10 exists. I'm going to smash my keyboard open. Come on. Come on. Oh, you son of a gun. Oh, you. Oh, you. Okay, wait. Let me make a new transaction. See if it works in here. Come on. And now it's not even. Okay, this is great. This is just great. This is just great. How are you all even doing your quests? I don't understand how you're all doing your quests. I mean, maintaining sanity. I don't get it. But let's send it. Also, all right. I'm gonna give a 10-second rant, and after this rant, I'm not gonna rant anymore. But I am so sick of this playground being not fixed because if you can't even get your like if you can't even fix this, how is anyone supposed to develop in the Flow ecosystem? Like the most important thing should always be helping people start, right? And if you can't even do that, then what are we doing? Okay, rant over. Um, so I guess we just can't test this, but let's try one more time, I guess. I don't know. Let's try with like 5. I don't know. Okay, I guess it's working. Oh, okay. Well, I don't know. Apparently I yelled at it and now it's working. Also, was someone going to say something? Okay. Um, Yeah, so anyway, it worked, right? So we withdrew it, we logged the name, and then we had to deposit it back. Anyways, this is all to say that it stinks, right? This is super annoying to do, and in the real world, you don't want to do that. Primarily because, let me give you an example. Let's say Raven has an NFT collection, right? And I want to read the name of one of Raven's NFTs. What would I have to do? I would have to withdraw it, log the name, and deposit it. But can I withdraw from Raven's collection? No, I can't, right? And if I could, I would just take all your assets, right? Obviously, Raven, I would just steal everything from you. So that would never work, right? You can't withdraw something to read the value and put it back because in a lot of cases, first of all, you can't even do that. All right, I'm gonna mute that. In a lot of cases, you can't even do that, and number two, it just doesn't make sense. So this is where references come into play. So I know we took a long time to get here, but references are how we fix this issue. So a reference is something that allows you to like perform some action on something or read the values of it without actually moving it, right? It's almost like passing around like something that you can use to interact with it, but it doesn't actually go anywhere. It stays in the same spot. So let's call this public function borrow reference. We're going to ask for an ID and we're going to return a reference. Now here's another symbol. A reference has an and sign in front of it, an and sign. So and test, okay? That means we have a reference to a test, okay? So what we're going to do is we're going to return, and things are going to get a little complicated here, whatever, just stick with me here. Return self.test at ID as a reference to test. Now, as of a month ago, this would have worked. However, ampersand, sorry, I don't know why I said and. This would have worked a month ago, but there's actually a new update to Cadence where they introduced something called optional references, and so it's a bit different now. So remember what I showed you before, that self.test at ID, this is an optional type, right? Because we're going into a dictionary. And when you go into a dictionary, it's an optional type. So this is actually, you don't do that, right? Yeah. So you go into you're going into a dictionary. There's an optional type. So the test, it's not a reference to a test. It's a reference to a test optional. All right. So technically, if you wanted to, you could just. What's going on? Oh, I forgot this symbol. Yeah, sorry. Okay. All right, let me restart. I was explaining that. Okay, I hate how I explained that. I'm going back. Your instructor didn't explain that right. Okay, sorry. So we're going to return a reference to self.tests at ID. All right. Now, when you're getting a reference to something, you always have to do something called a typecast. And a typecast is when you basically tell Cadence what you're expecting the type to be. So we have to say as a reference to a test, okay? But like I was explaining before, because this is a optional type, you have to put the little optional symbol here, right? Because you're actually borrowing a optional reference, right? Because you're going into a dictionary. And then we can simply return a reference optional here. So again, just to go over this again, you go into the dictionary to get the value. You make it, you tell Cadence it's a reference. So we're not actually going to move the value anywhere. It's still going to stay there. We just want to make a reference. And then you have to typecast it, say, okay, Cadence, we're expecting, as we want it to be, a type of a reference to a test optional. Now, if you wanted to not return an optional like this, you could simply wrap the whole thing and put in a force unwrap or a panic or whatever you want, right? So like that, right? So you could do either one. And most often, actually, you'll see it done like this, where you return a non-optional and you just unwrap the whole thing. So we're gonna leave it like this for now because I think it's better to see it this way. Okay, so let's redeploy this contract. And now what we can do is let's go ahead and deposit one. So let's deposit an ID of 10, and it's going to be BAM. So let's deposit it and hope this works. It worked. Yes, Playground, thank you. And now let's go into a script. And what we're going to do is we're going to return a reference to a hello world.test, right? So we're going to return hello world.borrow reference and pass in an ID, which will come from the arguments list right here. So let's pass in 10 because we know that exists. We were so close, everyone. We were right there, right on the cusp of greatness. We were right on the edge of just conquering this lesson. We were just on the edge of greatness. But the playground said, not today. Let's make another script and hopefully this works. Remember at the beginning of this boot camp when I told you all that like the playground was a meme? I don't know if any of you believed me, but as you can see, it has definitely become a meme. And after being a meme for 4 months now, it still has not been fixed. But I guess that's okay? Question mark. So let's try it again, and still doesn't work. All right, cool. Every time I say let's just pretend, I can't bring myself to actually pretend because it just makes me so annoyed. And I want to show you all that I'm not lying to you as your instructor. I promise. I know what I'm doing. I promise. All right, let's try 5. I don't know. Okay, it's still spinning. Cool. Come on. All right, let's try. Let's just type in 5 and see, hopefully it says not good. Ugh. Yeah, I mean, I met Roham like a month ago, and I forgot to tell him, so my fault. All right, here's the deal. All right, I'm telling you, this always works. All right, it sounds cringy, but somehow it works every time. I need everyone in the chat to put some clapping hands. Put the clapping hands emoji, and we're gonna encourage the playground to work. Everyone put them in the chat. I don't care. I don't care if you don't want to. You have to put it in there. If one person doesn't, it's not gonna work. Come on, put the claps in there. All right, we got the claps. All right, come on. Let's add a new script. Here we go. Let's call it I love you. And let's put our script in there. Right? Right? Here we go, ladies and gentlemen. Let's put in the 10. This has been unstoppable. This always works. Oh, no way, man. That always works. I'm literally not kidding. If you've been in the previous boot camps, that has always worked. That's so sad. Someone, did Numini clap? Everyone, let's go back in the chat. Oh my god. Oh my, oh my god, Numini. Are you serious? Oh no. I think that needs to be a timeout. All right, Numini, send a clap. Numini, you got to send a clap. Let's see. Come on. Send one, or you're not allowed to participate. Try. What are you trying? You have to send one, or it's not going to work. No wonder it didn't work, honestly. Yeah, Numini, just type that. Just copy paste that. Well, looks like we're dead. Oh well, all right. I guess it. Look at that. I'm telling you, it works every time. When everyone claps, it works. I'm telling you. I'm literally not kidding. Anyways, back to the lesson. We're already. It's a miracle. I'm telling you, it's a playground miracle. So we're back to here. Anyways, you can look at it again. So here we go. We return the reference, and the point is that, look, you can see it right here. The ID is 10. The name is BAM. And the coolest part is that we didn't even have to move the resource at all. The resource is still in the dictionary. We just returned a reference. We just returned a reference to it, which let us do some cool stuff. Now, one last thing I'll tell you before you have to go. I'll do this really quick. Is just like structs, you can also put functions inside of resources. So let's do public function update name. Update name. New name is a string, right? And it will say self.name equals the new name, right? So you can and let's make this var, right? So you can also put functions in resources just like in structs. So let's redeploy this. I'm trying to go really quickly this time. I'm not going to make any jokes. I know people got to go, but let's come on. Yes. Okay, good. So we added a function. Now the cool thing is that what we can do is with a reference, like I told you, not only can we read this information, we can still call this function and not even move the resource. So let's go to a transaction. Let's call this change name. Change name. And we can go to 3. We can say let reference equals hello world dot borrow reference. Pass in the ID. Let's just say 10. We can say ref dot. Why am I not getting compile? Ref dot update name. Say new name is actually going to be Jacob, and then log ref dot name, and we're gonna log it before and after. Okay, just like this. So before we do this, let's make sure to deposit one because we redeployed the contract, so it no longer exists anymore. So let's send one with 10 and bread. Let's send it, please. I can't. Okay, well, listen, I will stick around to do this afterwards, but if you can't stick around, the point is that this deposits the resource, right? We've already done that. And then what change name will do is it will borrow the reference, it will log the name, update the name, and then log the new name, right? So this would have logged bread, and this would have logged Jacob. Okay, so if you have to go, you can go. I'm gonna stick around and try to get this to work so I can show you all. Okay, it deposited, right? So it deposited. So if we go to this one, and I passed in 10 here, and let's send this one. So there you go, right? Bread and Jacob. Okay. So the cool thing is that this also stays, right? We just sent this transaction. So if we go back to our script here, right, and we read it, and we pass in 10 here, Let ref equals this, and then return ref.name. Come on. There it is. We get Jacob. See? There it is. So even though when we initially deposited it, it was bread, we called this transaction to change the name into Jacob. And then when we did the script, it is officially Jacob now, right? So it's permanently changed. Okay, so anyways, sorry we went over. I hope that was fun, and thanks everyone for sticking through all this playground shenanigans. It's been a mess for 4 months, and it's still not fixed. So annoying. Oh, I have the floats as well for you. Yep. So if you have any questions, I'm going to stick around afterwards. Feel free to ask, whatever question you have. Don't be afraid to ask. I'll be here. And here is the event for you all. The code is resources. So resources, I put that in the chat. I'll actually type it right here for you. So the code is resources, just like this. All right. So thanks everybody. If you claim the float, you're free to go. You're free to leave class. And I'll see you all on Friday. Otherwise, I'm gonna stick around and answer some questions, but don't feel like you have to stay. Okay? How do we complete boot camp? By finishing all the quests. Yep. We could, Numini. We're in the process of sort of changing this front page. But to be honest with you, like burning is not the main attraction of float. It's not really the main point. It's really to help people just like burn them if they want to. So that's why we left it here. When you go to your floats tab, you can click on this incinerator and you can go to it from there. But we will consider it. We will definitely consider it. No other way to code cadence besides the playground. Well, here we got a suggestion. Let's test this out. We got some live assistance. See if we can get this to work. Oh, true. Yeah, I probably won't do that then. True. You're probably right, Amit. I probably shouldn't do that right now. But okay, here's what I'll do. We'll test it and we'll ask around, and if it works, then we'll use it next time. All right. So, yep. All right, everybody. That's it. I'm so hungry. Um, locally, will it work better? I mean, maybe. I feel like it would, Amit. Yeah. I don't know how to do that though. Oh no, you can because you can just clone it, right? Yeah. Yeah, I don't know, Amit. Well, yeah, I mean, Amit, like the playground's been buggy since 2020. It's like almost like never worked, but it's definitely gotten worse over time, that's for sure. But I mean, I think it's, of course it's going to happen because, as cadence upgraded and all these things changed. Good night, courtside. See you, Raven. Um, yeah, you can, Didi. I've done that on YouTube. Thanks, Crypto Chica, for coming. Bye, Numini. Generous Kid, the code is resources. Thanks, MPI. Yeah, hopefully, Amit. Boaz here, actually, the IT guru, is actually also developing a playground as well, for emulator, testnet, and mainnet. So we're definitely looking forward to that too, and we're probably going to be using that in the workshops. Thanks, generous kid. Bye, Bread. Yeah, you got it, DD. Thanks a lot. Yeah, absolutely, admit. Yeah, the second it's ready, I'll send it right over to you. And also, sort of as a side note, we're only, I think, like a couple chapters away from like metadata on NFTs. So we'll be talking a lot about the like the metadata tool that you sent me that I got to do a video on. Yeah. All right. See you all on Friday. And on Friday, we're actually going to, yeah, NFT catalog. On Friday, we're actually going to be giving a quick introduction of Touchstone. So everyone who comes to the workshop on Friday will have the first look at Touchstone. And then, obviously we have the town hall after that. But anyways, I love to ramble. All right. Peace, everybody. Bye bye.